Hi, this is Jeff Spencer, Math 135 instructor for the Community College of Denver. And this is a quick video to explain per capita rates, just to show you how they're computed and how they get these particular figures for really per capita for any statistic. I'm going to show you the technique of how they get it, but I'm going to use this graph from classwork number 1 to show you the computation. So for this problem, I picked this graph and I find it really interesting because it's showing a couple different variables. But it's always good to think about what the population of any graph is, or what the sample is, depending on if the graph is showing a population census results or sample results, what the individuals are, and what the variable is. And what's interesting about this particular graph is it shows two different variables. Road traffic deaths per 100,000, that's a per capita statistic, or a per capita variable for different areas. And then we have vehicles per 100,000 population. So what's interesting about this graph is that really what it's showing, it has an interesting population. It's really mainly, or sample, sorry, of countries, but it also gives you the same statistic for continents. So really we have a sample of, we have a sample of countries, and then we also give a small sample of continents. So the first statistic, or variable, excuse me, that they're looking at is road traffic deaths. Our individuals are countries. We have a sample of countries and continents. And the road traffic deaths per 100,000, which is a per capita statistic. Now, the main part of this explanation is to tell you why per capita is a great statistic or variable to use when you're comparing countries, because they all have different populations and different sizes. So this is a way to control for the difference in population. That's a term we use in statistics, that we adjust for the difference in the sizes or populations of the country so that we can get a fair comparison. So the question on A says, well, let me just read a couple statistics. So basically, like if you look at China, they're showing that they have about 18 road traffic deaths per 100,000 population. So for every 100,000 people in the country, about 18 of them are going to die per year from road traffic accidents, which, seems pretty low. The United States is lower than all these countries. So the first question says in 2013, the United States had approximately 35,250 road traffic deaths, while Thailand had less at approximately 24,200. Why does the graph show Thailand having a larger figure? So Thailand's up here, and the United States is down here, but what I'm trying to tell you is that now, given the raw figures, USA has a frequency of more road traffic deaths, but why are they so much lower, or why is Thailand so much higher? Well, if you understand per capita statistics, you'd understand that Thailand is much smaller of a population than the United States. So this figure is relatively close to the United States, and the fact that they're so much smaller, that's why they show up to be higher on this scale for this variable. But let me show you the math behind it if that doesn't make sense to you. But remember, per capita is a way for controlling for the difference of the population and just comparing to a group of 100,000 people. If the country only had 100,000 people, how many people would die from this thing? So let's do the math. That's part of the main part of this video. So here it says the United States has 35,250 road traffic deaths. The United States population in 2013 was about 316.1 million. So I'm going to set up a proportion and show that, let me go back here, 35,250 road traffic deaths in the United States for a population of 316.1 million. 316.1 million, so there we go. All right, that's the ratio of road traffic deaths to the entire population. And then let's do the same thing for Thailand. So Thailand had 24,200, and their total population in 2013 is about 68.14 million. So 68.14 million would look like this. Oops, sorry. 140,000. All right, so that's their individual ratios. Okay, so let me press pause. I need to set a separate proportion up for both of them. Okay, sorry that I had those equal to each other. I meant to do their separate proportions for each country. So the US is on the left, Thailand's on the right. So the way you do this is if you know the total number of a statistic to the total population, then you can set up a proportion saying, well, if this is the portion for the totals, then why don't I figure out how many for 100,000 people? And you do the same thing over here for Thailand, how many per 100,000 people. And if you remember how to solve a proportion, the technique is to cross multiply, which means I do 35,250 times 100,000. I do this times x, and then I divide by this 316 million. So really the shortcut is to take these two numbers and multiply, because I'm going to get that equal to 316 million times x. Then I have to divide by 316 million. So I'm going to do that with the calculator here. I have to do first 35,250 times 100,000, and then divided by 316 million, 100,000. Make sure I do this right. 2, 3. And it shows 11.15. Now let's see how closely that matches the graph, because I actually just looked these numbers up on Google for the population. So let's see how close it is. Yeah, there it is right there. The United States is right at 11 something. Okay. Now, let's do the same thing for Thailand. They have 24,000 total accidents, but their population is only 68 million. So let's see how that comes out to be as a number per 100,000. So I do the same thing. I'm going to do upper left times lower right divided by the lower left. So 24,200 times 100,000 divided by 68 million, 140,000, 35.5. Okay, and you'll see, let me write these results, that Thailand is right at 35.5. Okay, so to show the US is at 11.15 or whatever it was, and Thailand is at 35.5, basically 5.2. And that's where they are on the graph. So that's the point. The idea is that proportionally, the United States is much lower because they have a much larger population than Thailand is. So this is a lot of deaths for such a small country. If you want to show another method real quick for the United States, I'll show this technique. It's actually, some people would do it this way, and I'm okay with this. They would just take the total number of accidents divided by 360 million to figure that out as a percent of the population or a proportion. So you could do 335,250 divided by the total population, 316 million, 100,000. Problem is this number is so low, so that it's hard to understand this as a proportion. Remember, this e times the -4, or e -4 means times 10 to the -4, which means that this decimal goes 4 spots to the right. So it's 0.000111. So, but this represents the number of traffic-related fatalities per one person. That's what happens when you divide it like this. This tells you how many accidents per one person, but it's weird to think of 0.0001 accidents happening per person. So why don't we multiply that by 100,000 people to figure out how many we get for 100,000 people? And it should be the same number, like 11.15. So that's another way to do it if you want. Real quickly, just to show you, the other variable on this shows you that this is vehicles per 100,000 population, which is different than road traffic deaths, obviously. And really one of the main things that this graph is trying to show you is that while Europe has the most vehicles per 100,000 people, basically it's almost about half of the people have vehicles, they have the lowest traffic-related deaths compared to the other two continents in the world that they're compared to. Notice how Africa has a high number of traffic-related deaths, but they have the least amount of cars. So that's the main point the graph's trying to show you, but I just wanted to explain the per capita and how those numbers come about and how they really control for the difference in population. And by control, I mean minimize the difference or eliminate the difference in that comparison, the difference in population. So see you next time.